Okay, so question 18 is to draw the Lewis diagrams for these 5 acids, HBr, and then it increases by 1 oxygen. So let's find out the total number of valence electrons. And maybe to make it easier, I'll just do this in like chart form. So let's have HBr, HBrO, and I'll just write all the valence electrons in this table. So when we have HBr, hydrogen has 1 valence electron. I'll just write it up here. Hydrogen has 1 valence electron. Bromine has 7. So HBr just has 8 valence electrons in total. And once we add an oxygen, oxygen has 6 valence electrons. So we just need to add 6, and we get our count for HBrO, which is 14. Adding an additional 6 gives 20 valence electrons. Adding another 6 is 26. And lastly, when there's 4 oxygens, we have 32. Okay, so now let's just start to draw them. So HBr, there's 8 valence electrons. So it's pretty straightforward. We just need to do a single bonded hydrogen with a bromine. And then we can show all of the lone pairs on the bromine. And we have our total of 8. Now let's do something similar with our next compound. So this time oxygen will be our central atom. And I'll show 2 single bonds to the bromine and the hydrogen. And then I'll fill in all of the lone pairs. So now everything has a full octet. And if we count it out, with each bond containing the 2 bonding electrons, we have 14. And you can see that there's just an alcohol group in this structure as well. So now let's see what happens if we have an additional oxygen. We would still have our single bond like so. This time another oxygen is added. Let's draw a single bond to this oxygen. And this time, a double bond can be formed with the bromine and the oxygen. And if I draw out all the lone pairs and count out how many I have in this structure, we're expecting 20, and we have 20. So this is also a valid Lewis structure for our third compound. A single bonded oxygen with the hydrogen, and then a double bonded oxygen. And everything should be neutral. And now let's do our fourth compound that has the extra oxygen. We'll still have this single bond to this hydrogen. And bromine is able to just form 2 double bonds to these oxygens and still containing a lone pair. And now let's double check to see if we have 26. Okay, so we have 26. So this is our fourth compound. And lastly, when we add yet another oxygen, as you would expect, there would just be another double bonded oxygen attached to the bromine. So bromine is one of those atoms that can be an exception to the octet rule, in which it can have it can have more than 8 bonding electrons attached to it. So these are all the 5 different Lewis structures for these acids. So now let's see what the junior tutor said. For HBr, list the elements, their valence electrons, and determine the total valence electrons. If a charge is present, add the value of the charge to the total valence electrons. When it is a negative charge, subtract if it is a positive charge. So they have 8, and they showed the skeletal structure. And when you add the remaining valence electrons, you have your final Lewis structure, so that's correct. So when we add an oxygen, the total valence electrons is now 14. So this is their skeletal structure. And this is their final Lewis structure as well. Adding an additional oxygen. So we have 20 valence electrons. And they showed how there's a double bond with one of the oxygens. And then they distributed the remaining valence electrons. Okay, so that is correct as well. Adding an additional oxygen, valence electrons is now 26. And their Lewis structure has 2 double bonded oxygens and a single lone pair on our central bromine. And finally, when we have the 4 oxygens, the total valence electrons is 32. So we can have 3 double bonded oxygens to our bromine. And when we show all of the different lone pairs, you get your total of 32 valence electrons. Okay, so this solution is correct.